evening, and since this is our first program of 1989, a very happy new year to you all. And it's going to be a fascinating year. So much is going to happen. We're going to have the Russian probe to Phobos, the tiny Martian moon. You know, so far, the Russians have had no luck at all with Mars. Let's hope they do better this time. Then, in August, Voyager 2 is going to go by the outer giant planet Neptune, and that's going to be quite fascinating. And then, right at the end of the year, with any luck at all, we should have the long-awaited launching of the Hubble Space Telescope. And I can assure you that the sky at night will cover all these in great detail. Meanwhile, let's have a look around the sky as we see it now. And we still have one or two planets on view. We have Venus, which rises shortly before the sun. It is running into the dawn sky now, and of course, you can never see very much on it. But in the evening sky, we still have Mars. Now, that was a drawing I made with my 15-inch reflector a few weeks ago, and you could then still see the tiny south polar cap there right on the top of the picture, and also many of the dark markings. But Mars is getting further away all the time, and by now you need a fair-sized telescope to see anything at all. There's no opposition of Mars in 1989. We won't see it again really well until 1990. But we do have the brilliant Jupiter, also in the evening sky, in the general area of the Hyades and the Pleiades. And you can't mistake Jupiter because it is so brilliant. Telescopically, you'll see the belts and you see the bright zones. You won't, I'm afraid, see the great red spot. It's not on view at the moment. But in that drawing, you can see the red spot hollow, which marks the position of the spot. No doubt it'll come back before long, because it always does. But this evening, I want to concentrate more on the stars and to deal with some minor but intriguing mysteries, some of which I can explain, and others, frankly, I can't. Let's begin, as we so often do, with the Hunter, Orion, now high in the south, which will dominate the entire evening sky right the way through for the early spring. With its two brilliant stars, the orange-red Betelgeuse, big enough to swallow up the entire path of the Earth around the sun, and the Rigel, which is equal to 70,000 suns put together. You can't mistake Orion. In mythology, Orion was a hunter, and there's one of the many representations of him. I'm not going to say that the pattern reminds me very much of a hunter. Here's a lovely photograph taken by Ron Arbour, shows Betelgeuse and Rigel very well, and the belt. And the three stars of the belt point downwards to the brightest star in the sky, the dog star in Canis Major, Sirius. And incidentally, Sirius is a Greek name, not an Arab one, and I'm told it really should be Sirius, not Sirius. Not that it really matters. Anyway, no one really knows how these old names were pronounced, and pronunciation experts, please don't write to me about it. Anyway, there is Sirius, and you can't mistake it. It's a white star with a surface hotter than the sun's. It is far brighter than any other star, and it's pure white. But it does seem to twinkle very obviously. Now, this twinkling has nothing directly to do with the stars themselves. It's due entirely to the Earth's dirty, unsteady atmosphere. Because, remember, the starlight has to come to us by way of the Earth's mantle of air. When a star's nearly overhead, its light's coming to us through a much thinner layer of atmosphere, and it doesn't twinkle very much. A star which is lower down will twinkle more because the light's had more atmosphere to traverse. And Sirius is the supreme twinkler, partly because it is so brilliant, and partly because it's well south of the equator of the sky, and therefore from Britain it's never very high up. So it seems to flash various colors of the rainbow. It also has a very faint companion, often nicknamed the Pup, although better known as Sirius B. And this photograph shows it. Sirius itself is very overexposed, and of course those spikes are purely photographic effects. But you can see the little Pup star there, above the main star, only 1/10,000th as bright. And the Pup is a very old star that's used up its nuclear energy and has now collapsed. It's what's known as a white dwarf. It's very dense, about 60,000 times as dense as water, and by stellar standards, it's very small. In fact, it's smaller than a planet such as Uranus, as you can see here, even though its mass is equal to that of the sun. You can understand, therefore, it is very dense indeed. Now, there is a mystery associated with Sirius. As I've said, it's purely a white star, and yet many of the astronomers of 2,000 years ago described it as red. And although it does seem to twinkle so strongly, it certainly isn't red now, and no one can say it is. So either there's some kind of mistake, or else there's been a change. Now, I don't think there's any chance at all that Sirius itself has altered. It's not that kind of a star. It's a steady, well-behaved main sequence star, about 26 sun power. So if there has been any change at all, it must be in the small companion, the Pup. Now, as I've said, the Pup is a white dwarf, a very old star. But before a star becomes a white dwarf, it goes through a red giant stage. And the suggestion been made that 2,000 years ago, the pup may have been a red giant or went through a brief red giant period. That's a lovely idea, but frankly, I don't think it holds water for two reasons. First of all, the time scale's all wrong. And secondly, if you had the present Sirius together with a red giant, then the total brilliancy would be about as great as that of Venus, and there's no indication of that. So frankly, I don't think there is any change there. I think we are dealing with a mistake in interpretation or observation, probably interpretation. All the same, it is interesting. And there's another minor mystery associated with the two twins, Castor and Pollux. Here we are back to Orion. We have Sirius, Procyon and the little dog, and the two twins, Castor and Pollux, which look close together, even though they're not, in fact. They are more than 10 light years apart. Castor is the further away. Look at them, and you'll see two things. First of all, they're different in color, because Pollux is orange and Castor is white. Secondly, Pollux is half a magnitude the brighter of the two. And yet, 2,000 years ago, it was said that Castor was the brighter. So once again, has there been any change? I doubt it very much. Pollux is an ordinary orange star. Castor is a kind of family party. With the naked eye, it appears as one. With a telescope, it's seen to be a wide double star, and each of those is itself a close binary. And there's also a fainter companion, which again is a binary. So Castor's made up of 6 individual stars, making up a kind of multiple star. And this, of course, is not a photograph. This is a drawing by Paul Doherty, showing what you might see if you lived on a planet in the Castor system, although whether there is a planet there is very much a matter of debate. So Castor is a multiple star, Pollux an ordinary orange star, and once again, I very much doubt whether there has been any change, although it's difficult to explain why the ancients said so definitely that Pollux was the fainter of the two. Gemini itself is a rich constellation, is crossed by the Milky Way, and if you take binoculars and look at the two end stars in Gemini in the general direction of Orion, you will see near there an interesting open cluster, Messier 35. Nothing very special about it, but it is worth looking at. Almost overhead is the brilliant yellow star Capella in Auriga, the charioteer, which has the same surface temperature as the Sun, but is 200 times as luminous, and again is a very close binary. Close to Capella is the little triangle of stars making up the so-called Kids. And the top one, which hasn't got an individual name, we simply call it Epsilon Aurigae, is a very odd star indeed. It's a luminous yellow supergiant, at least 60,000 sun power, and a very long way away. But every 27 years, it very slowly dims down by about a magnitude, remains faint for a year or so, and then equally slowly recovers its lost light. So clearly, something is getting in between us and it, and that something can only be a binary companion. But nobody's ever seen it. We have no real idea what this mysterious companion can be, and all kinds of ideas have been put forward. Originally, it was thought that the eclipsing companion might be a very young star, still condensing, and not yet hot enough to shine, although dense enough to obscure the main star when it goes in front of it. That's one idea. But for various reasons, that didn't seem to work, and it was then suggested that the companion might be a more or less shapeless mass of gas and dust. But there are objections there too, and nowadays it's more generally believed that the eclipsing companion is a fairly small, hot blue star surrounded by a shell of fairly dense gas and dust. And that may be the answer, but we don't really know. And since the last eclipse ended a couple of years ago, it's going to be well over 20 years before anything more happens. And until then, Epsilon Aurigae will look like a perfectly ordinary star, although it most certainly is not, and we don't know of anything else quite like it. Now let's turn to the cluster of the Pleiades, beginning with Orion, following up the belt to Aldebaran, in the cluster of the Hyades, which you can see extending in a kind of V of stars from the orange light of Aldebaran. And incidentally, Aldebaran itself is not a true member of the Hyades. It merely lies about halfway between the Hyades and ourselves. Going on further, we come to the Seven Sisters, or Pleiades, and you can't mistake them because they are so obvious. They're very easily seen with the naked eye, and they must have been known since prehistoric times. When photographed with large telescopes, it's seen that they're very populous. That picture also shows nebulosity, which indicates that the stars are comparatively young and bluish and very hot, and star formation there is almost certainly still going on. Of course, not all the stars you can see there are members of the cluster. Some are background stars. But you can see individual stars with the naked eye, and that's a small-scale picture I took some time ago, and you can see, well, quite a number there, more than you can actually observe with the naked eye. And the brightest of the seven is called Alcyone, or Eta Tauri, which is of the third magnitude. There it is. And not far away from it is a much fainter star called Pleione, which is right on the limit of naked eye visibility. Now, we call this the Seven Sisters cluster, and it's certainly true that people with average eyesight can see at least 7 stars with the naked eye on a good night. It has been suggested, though, that in olden times there was an extra one, and we've heard a good deal about the missing sister. And I suppose that could be Pleione, because Pleione is an unstable star. It periodically throws off shells of material and brightens up for a bit. On the other hand, again, I take this story of the missing sister with a very large grain of cosmic salt, simply because the number of stars you can see with the naked eye varies so tremendously according to your own eyes. 7 may be the average. Some people can do better, and I believe the record's held by a last century German astronomer named Eduard Heiss, who apparently could see 19. So, frankly, I don't believe there's any real mystery here. But there is one minor mystery which I find very much less easy to explain, and that concerns a star in Ursa Major, the Great Bear. Now, Ursa Major never sets anywhere over Britain. We all know the 2 pointers, Merak and Dupé, and they show the way to Polaris, the pole star, which marks the northern point of the sky. The second star in the plough handle, or the bear's tail, is called Mizar, and close to that is a much fainter star, Alcor, and there's no problem at all in seeing Alcor with the naked eye on any clear night. Telescopically, Mizar itself is seen to be a double. It really is a binary system. And in that poor dirty drawing, the 2 Mizars are near the bottom, Alcor's near the top, I'd say easily seen with the naked eye, and in between there's a much fainter star, often known as Ludwig star, which you can't actually see without a telescope. Now, here is the mystery. The Arabs of 1,000 years ago said quite definitely that Alcor was a test of naked eye vision, and you couldn't see it unless the sky was very dark and very clear. Now, the Arabs were keen-sighted. In those days, the skies were much less polluted than they are now, and yet today, Alcor is perfectly obvious to anyone with even average sight on a moderate night. So what's the answer? Either there's been some change at Alcor, which I very much doubt, or there's a wrong description, or else possibly the clue might be in Ludwig star, between the two, which is now very much too faint to be seen with the naked eye, but I suppose could have been brighter 1,000 years ago. I'm not going to say I like that idea very much. Frankly, I don't. Ludwig star is not a genuine member of the Mizar system. It's further away, and it doesn't seem to be a star which might be variable. On the other hand, it is a mystery, and I can't explain it. Anyway, there's no doubt at all that the Arabs did say that the Alcor was difficult with the naked eye, and now it's perfectly obvious. So there is definitely a problem there. Now let's turn to something rather different. Let's go back again to Orion. There we have Betelgeuse, right from the belt, and below the belt we have the misty sword, marked by the great nebula Messier 42, a huge cloud of gas and dust more than 1,000 light years away from us. And that is a kind of stellar nursery where fresh stars are being born, and we've even caught some of them in the act. There's no problem at all in seeing the Orion nebula with the naked eye. And there's a small-scale picture of it, taken by Commander Hatfield. The nebulosity is perfectly obvious. Although, of course, photographs with large telescopes are needed to bring out its immense complexity. And it really is a magnificent sight, as you can see in this photograph here. The colors, bear in mind, are not visible visually. They are purely photographic. They exist, but they're too faint to be seen at the eye end of a telescope. Now, here's the mystery. As I've said, the Orion Nebula in the sword is quite clearly visible with the naked eye. And yet nobody mentioned it before the year 1610, and that was the year when the telescope was first turned toward the sky. And the Orion Nebula was then mentioned by an otherwise obscure astronomer named Nicholas Puresque. So why wasn't it recorded beforehand? Many fainter things actually were. I absolutely refuse to believe that the Orion Nebula waited until telescopes came along and then brightened up. But all the same, it is a curious puzzle. And the first really good description of it was given much later, in 1656, by the Dutch astronomer Christian Huygens, who was probably the best observer of his time. And he was using then one of these strange, long-focus, small aperture refractors. This one was 23 feet long, and as you can see, the object glass had to be fastened to a mast. And how anyone ever saw anything with telescopes like that, I simply don't know, but they did, and Huygens gave quite a good description of the Orion Nebula. Later on, it was drawn by the 3rd Earl of Rosse with his 72-inch telescope, before photography came along. And there is the Rosse drawing. And it may look rather crude, but when you compare that with a modern photograph, I think you'd agree that for a visual observation, it is pretty good. And so why did no one record the Orion Nebula before 1610? Frankly, I don't know. And there's another mystery too. The Orion Nebula is lit up by the 4 hot stars making up what we call Theta Orionis, or the trapezium, for rather obvious reasons. There, in that lovely David Nalin photograph, we see the trapezium near the center of the picture. It really is a multiple star, and those stars are very hot, very young, not more than 100,000 years old, and that, by stellar standards, is very young indeed. And they are lighting up the dust and the gas, and also having an effect upon the hydrogen in that nebula, and making that hydrogen fluoresce, so it's giving out a certain amount of light on its own account. So that's why the Orion Nebula shines. As I've said, it's more than 1,000 light years away. It's also very large, more than 30 light years across. Here again is a picture. There, the size of M42, and compare that with the distance between Sirius and ourselves, only 8.5 light years, or between us and Alpha Centauri, the nearest star, only just over 4 light years. So the Orion Nebula really is huge. And yet it's very rarefied. If you could take a core sample and go right the way through it and come out the other side, the amount of material you collect would weigh less than a pencil. And yet even so, there is so much material there that fresh stars are being formed inside it. There are also 2 mysterious things, BN and KL. As I'm sure you know, visible light makes up only a very small part of the electromagnetic spectrum. To the short wave end, we have ultraviolet, X-rays and gamma rays. To the long wave end, infrared and radio waves. Now, these 2 objects, BN and KL, named after the astronomers who discovered them, are not visible telescopically because their light is blocked out by the dust in the nebula. They can be recorded only in infrared. And here's an infrared picture. Not, of course, a genuine photograph. Those colors are false. BN's the blob at the top, KL's the rest, and this is a kind of a contour map with colors added. And what exactly are these? It's believed that BN is a huge superluminous star, about 1 million sun power, which we can never actually see because its visible light's blocked out. And KL may be made up of several stars in the process of formation. And certainly there is evidence of very quick-moving material there, flashing along at something like 17,000 mph. But we'll never see these things. We can detect them only by their infrared, and we may be wrong about their nature. We think that's what we are. We can't be certain. And incidentally, the Orion Nebula is only part of a huge molecular cloud covering most of Orion. And near the bottom star of Orion's belt, Zeta Orionis or Alnitak, we see the Horse's Head Nebula. And that's a dark nebula looking remarkably like the shape of the head of a knight in chess. And the only difference between that and a bright nebula is that with the Horse's Head, there's no suitable star to light it up. And I may say that although it's not difficult to photograph, it's very difficult indeed to see visually. You try it and you'll see what I mean. So the Orion Nebula is truly a fascinating place, and when you look at it, reflect that more than 4,500 million years ago, our sun was born in a nebula in just that way. Well, it's newsletter time, and if you want your newsletter, then as usual, send your stamped addressed envelope to newsletter number 32, The Sky at Night, BBC TV, London W12 8QT, and you can also see us on CFAX page 289. Next month, I'll be joined by Professor Michael Disney, and we'll be talking about very faint galaxies. Until then, good night, and once again, a very happy New Year to you all.
Now, Sky at Night will be back next week.